there is a difference between .NET Core and .NET Standard. The prior slide said .NET Core. I changed this one to .NET Standard because .NET Core is kind of like a subset of .NET Standard in that it is targeting your hyperfast web applications, console applications, and some other infrastructure in that area that they provide. However, this really isn't specific to one or the other, which we'll see as we get into that. So this is the overview for today. So first, for those who might be new to .NET, we're going to talk a little bit about what exactly a .NET NuGet, or what a NuGet package is. They are used for more than just .NET for Visual Studio. So I'll demonstrate really quickly how we use one in Visual Studio. And then after that, the rest of the time we're going to talk about building NuGet packages. Now this is going to be fairly centric to Visual Studio and the types of packages that I would expect you are interested in, being that you're here at the .NET user group. But know that it also works for other things. I noticed we have a couple of DevOps people. You can use this for, like, if you want to generate a NuGet package for PowerShell, for Octopus Deploy, or things like that. You can use it. You can use it for that too. So with that, that's, I guess, where we're going to stop. Oh, so a little bit more background. So what is a NuGet package, and what is it for? So a NuGet package is really nothing more than a container for content. And in our case, it is usually for storing code. So it'll usually be assemblies. In some cases, we might have a task file or a target file that we use to affect the build process within Visual Studio. You can do other things, right? We could actually say, hey, I want to provide not just the README that might pop up when you install a NuGet package, but I also want to provide actual source files. So those are other things that we can do. Now, a lot of you, if you have been in the .NET community for a while, will be familiar with the NuGet gallery. The NuGet gallery is where we see all of the standard published public NuGet packages. There are other repositories for NuGet packages also. So Chocolatey is an application used for installing software on Windows. And it's very convenient, right? So I could just say, hey, Choco, install this, and it actually uses a NuGet store to get that content. PowerShell. So if you are on a recent version of PowerShell, so recent being, so let's say the latest operating system, either server or even Windows, then you actually have a PowerShell gallery available to you that you can use to install different PowerShell packages. Okay, so with that, let's just jump into a demo here. So I'm going to go to Visual Studio. And we are just going to start a new project. That project is really not going to have anything, but we're just going to pull in a NuGet package so we can see what that process looks like. Hopefully it doesn't take too long. Okay, so in this particular one, we'll just do a new C# project here. And I think the recording is slowing down my computer because it's not usually this slow. So if it goes much slower, I will just stop recording. Okay. So I'm going to go just to my samples directory here. We're going to say sample NuGet consumer. And class library is fine. So right now I'm on .NET Standard. I could go to any of them, but we'll just go ahead with this one. So at this point, it'll create a NuGet project. So this is .NET Standard, which means the way it's going to pick up files are going to be slightly different than the older .NET applications. So rather than us having to specify the full set of files, it automatically picks up any that happen to end up in that directory. Boy, this really is going slowly. Okay, so I'm going to come over here and I'm just going to say add NuGet Package. So I'm going to manage those. And one of the things that we can see is we have a NuGet package installed already, which is the .NET Standard Library. So this would not be here if I was running the standard classic project. So if I was targeting .NET 4.5, 4.6, or something like that, I would not have any pre-installed. Now what we can do is I can come over here and I can see that, hey, the most common NuGet package right here at the top is newtonsoft.json with 70.4 million downloads. So that's a lot of them. Now, I can now come over here, I can click install, and it's going to give me the option of agreeing to this license, and as long as I accept, I can install that package. So one of the things that's nice about the .NET standard projects is now in the dependencies, so we can see that we have .NET, we have a NuGet section. And if I expand that section here, we can see that we have, it's out of sync. Interesting. Okay. Anyway, we have a NuGet package right here under this NuGet section. So we have the newtonsoft.json, which is what we installed. So that's really all there is to consuming NuGet packages. Now the rest of the time we will spend walking through how we use them. So now, as we move towards the technical, a NuGet package, as I said, was a container. What that container is it's a zip file. That zip file contains a manifest, basically a list of all of the files in that NuGet package that are expected to be present and what their purpose is for. Now, when you install Visual Studio 2017, you are automatically getting NuGet 4.1, which is the latest version of NuGet that is currently available. There is a 4.3 preview that's available at this location, at this dis.nugat.org site, if you wanted to grab that. But in Visual Studio 2015, we're at NuGet 3.5. Now, there are differences, subtle differences in those versions. So if I build a NuGet package with, say, 4.1, there are certain features that I can use that will make it so that package will not work on Visual Studio 2015 or anybody who is using an older version of Visual Studio. Now, you can update it so it's not running 3.5. You can install newer versions if you want. They are also available at this website, the dis.nugat.org. Just know that in some cases, like I said, there are features that will require certain versions of NuGet. That's an advanced topic. We're not going to need any of that for the standard NuGet packages that we're going to be doing today. Just know that it's available. Okay, so a quick NuGet primer. So NuGet is in itself a standalone executable. Now in Visual Studio there are integrations and there are suites of assemblies, if you go look through the Visual Studio directory, that allow it to do the integration with Visual Studio so that you have the whole, the manage NuGet packages and you can browse the list and all of that. But at its core it is just a executable that allows us to manage dependencies. The way that you typically use it is you have this verb, which is some sort of command that you want to execute, and then you have the options that that command accepts. So, for example, we have the help command. Obviously, this is very useful for finding out where we're going to start. I'll be running that here shortly, just as kind of a, let's see if we can figure out how we want to go if we were just to look at the help. And then we can say, well, I want help on something specific. So in this case, I can say, well, I want help just on the pack command, which is what we use to build those NuGet packages. Okay, the process for building a NuGet package is really 3 steps. It is generating a new spec file, which is the source for the manifest that ends up in that NuGet package. We then, if we generate it, we're going to have to fill in some of the details. So we're going to have to modify it a little bit. Say, hey, I'm the person who wrote this. It's not going to know who we are automatically. And then after we've done filling in those details, then we're just going to run NuGet Pack, which basically will take the new spec file or another valid input source and use that to generate the NuGet package. So with that, we're just going to jump into PowerShell here, and we're going to start the process of building a NuGet package. So as I mentioned, there are other sources for NuGet packages besides just the NuGet gallery. So find package is the PowerShell version. So if I want to find, and it'll actually search not just PowerShell repositories, but it'll search other ones. In this case, I said I want to search the PowerShell gallery. And if I do a search for Pester, which is a unit testing framework for PowerShell, then it'll find all of those matches. So this is just one example of how we can consume that. Now, is this font large enough for everybody? No? Okay. So let me change the font size here. Properties. Let's go to, we'll try 28. Okay, how's that? Reasonable font size? Yep, okay. Okay, so we're going to go through a number of different steps. So we're going to start with building a simple app that has no dependencies. After that, we will take and look at a simple app that does have dependencies. When I say a simple app with no dependencies, what I'm talking about is we're going to build a package for an application that doesn't depend on other things. Then we're going to build an application that does depend on some other things. And then we're going to say, well, what if we have multiple dependencies? So for example, what if I have a project dependency as well as some NuGet package dependencies? And then after that, we're going to take a look at .NET Standard, which is also applicable to .NET Core. And then we will go through the process of, hey, what if I want one of these really fancy NuGet packages that works on like everything, right? I want it to work on .NET 1 all the way up to .NET Standard 1.6. The process for these two is roughly the same, and the process, well, actually, and even this one. But then the process for .NET Standard is going to be a little different, and then the process for targeting multiple frameworks is also a little bit different. But they're not so different that it should be completely foreign. So we're just going to kind of build up through that process. So with that, I'm going to go to our first little project here. Now, let's see. Let me go ahead and show you what our project looks like. Other and building NuGet packages. Okay. Okay, so this is probably a little small. Okay, so we have 3 different files here. So we just have a little interface. And let me just pin this. We have a concrete implementation. And if we look at the references, all we can see is we have Microsoft C# and then a bunch of system ones that are installed by default. So very, very bare project. No dependencies on NuGet packages or any non-standard system assemblies or anything like that. This does have a readme.txt file. I will post these to GitHub at some point. And this is kind of going to document the full process that we're going to go through tonight, but not in exactly the same way. Just know that this will eventually be available, so we'll kind of have it as a reference. So with that, I'm going to jump back to our console here. Yep.
As the screen was flying by, I saw NuGet Pack CS, and it had a CS proj file. Why would you include the stuff that Visual Studio cares about in the project file in the package? I'm thinking of a package as like a DLL or an EXE.
Why don't we walk through this?
Sure.
And if at the end of this particular one, this first app, we haven't answered your question, we'll bring it back up.
Okay.
Okay. So first thing, I'm just going to move the new spec file that I already built out of the way so we can see kind of what happens if we just say, if we target that CS proj file as he was just asking, what exactly happens. So first thing, I've already added NuGet to my path. So I can just type NuGet. This is equivalent to running NuGet help because I did not specify a particular command. And we can see that, hey, I can add a package to some hierarchical source. So I'll talk about those a little bit later. That's going to actually be at the very, very end. We can see that we have a number of different options. The main two that we're going to talk about tonight is Spec, Pack, and then we will talk about the add or push process at the very end. Okay, so with that, let's see. We know that we want to create a NuGet package. Pack is the command that does that. So I'm going to type NuGet help pack, and we're going to see what our options are. And as he was pointing out, there's a couple options. We can give it a new spec file, or we can give it a CS proj file, right? Now, if I don't have to create a new spec file, that sounds easier. So let's see what happens if I attempt this. So at this part, I have a simple app no-dep CS proj file. So I'm just going to run NuGet pack simple app no-dep CS proj. And okay, well, it looks like we created one. Note that we have a couple of warnings. So description was not specified. I am using description. And author was not specified using Pederson. Now that's my machine login, so that's where I grabbed that information. And now we want to take a look at that particular NuGet package. It's going to put it in the directory I execute that in, which means right here I now have this simple app no-deps new package file. As I said, this is a zip file. So if I say I'm going to launch my Explorer in this location, and let's just take a look at this. Now I'm going to go into 7-zip, and I'm going to open this so we can see what the full structure is. And I'm sorry that the font is small on this. So here is the new spec file. So it did create a new spec file for us. I will look at it a different way. And then there are a couple of folders that it has to create. It has to have this package folder, and it has to have this Rails folder. It also has to have this content types XML. So there are a few things in here that aren't particularly useful to us. They're not really human consumable. But then we have the lib. Here's our net 461 project, and you can see here is the DLL. So it did build it. It built our NuGet package, and it put in the correct location in this net 461 directory, which is the target framework that this particular project uses, the DLL of interest. Now, I actually have a program called Nougat Explorer that is installed. It is available on GitHub. They're actually looking for a maintainer. So if you want to become the master of NuGet packages and Nougat Explorer, I'm sure they'd be interested. But I'm just going to double click here, and we can see what it did. So it gave me a package with ID simple app no-dep. So it named the NuGet package after the project in question. The version just defaulted to 1.0.0, and then I don't have a very useful description. It says description, but it gave me a copyright and some owners and whatnot. But as we can see, we have no dependencies, and over here I can browse, and I can see that, hey, it's lib, that I am targeting .NET 461, and that we have the DLL in question. This also gives me the ability to see the actual new spec file. So now we have an idea what the new spec file looks like. It is an XML file where we have the version or the information that we just saw available to us. Okay, so we could use this as a template for creating a NuGet package if we wanted to. Okay, so we have generated a NuGet file, our NuGet package, and at this point we have some basic information, but it wasn't quite perfect. So let's say I want to customize that description, and I wanted to, customize some other value. Well, when we build against a NuGet package, it is actually going to take some of that information from the CS proj file. So I'm going to go ahead and open that up, so simple app no deps, we're going to open the CS_proj file, and we can see where it's getting. So this is going to be the ID. The version actually comes from the assembly info. So if I modify in this solution the version info here, it's going to use that version information here. However, we can override it. So just as we don't have a description, if we want to override the version other than what's specified in code, we can do that. Now, know that that means the version that's going to show up in, let's assume that we publish this to the NuGet gallery. That means the version that's going to show up there will be different than the version that shows up on the file system once someone is actually looking at that physical file, which may be confusing, right? So that's just something to keep in mind. We'll talk a little bit more about the versioning here shortly. We haven't talked about how that versioning is supposed to work. But for now, we're going to kind of continue on with, we have the CS_proj file, we need to start customizing it. So with that, I'm going to go back over to our PowerShell. So if we go back to that help unpack, we're going to notice that there is a properties option. This allows us to specify some of those values. So let's see if I can find it here. So description was not specified, okay? And then we have author was not specified. These two are properties that we can set. So if we come back to our pack command, so let's go NuGet pack, our simple app, no deps. We're going to give it our CS_proj file. Now, if I were to run that NuGet pack command, it's actually going to fail because Nougat Explorer locks that particular file at the time that it opens it. So I'm going to have to close this, and now I'm going to go ahead and specify those properties. So I'm going to say properties, and it is going to use the exact same syntax as MS build if you are familiar with that. What that means is we have a key followed by an equals followed by our value, my description, and then it's semicolon separated. So now I've specified a description. I can also specify the author. And I think it's case sensitive if I remember right, so I'm just going to capitalize that. And I'm just going to say Kaleb this time. So with that, we can rerun that, and ideally, we have gotten rid of those warnings. Nope. Okay, so let's try lowercase really quickly. Nope. Well, I guess even though we've tried, we have failed when using a CS_proj file. And this is where it becomes important that we start specifying the new spec file. The new spec file provides these tokens right here and right here that are not available to us. So at this point, we need to say, okay, we need to generate a NuGet package, and I'm just going to generate one to start with. So the command for that is say spec. So I'm going to give it that CS_proj file. So simple app no deps CS_proj, and it will generate the new spec file for us. So now I can come in here, and we're going to just take a look at this to start with. Okay, the tokens. So it is lowercase. What it's actually looking for when it's talking about that description and the author that weren't present are these values. So anything in this dollar, variable name dollar. So here is that description it was looking for. Here is the, here is the author it was looking for. Now, because we were using a CS_proj file, these other things, the title, version, ID, these were automatically pulled from the CS_proj file. And this is why it can process a CS_proj file. But if we give it the CS_proj file, then we don't directly, without specifying a new spec file, we don't have a way to specify some of the things that are of interest. Which is fine if you're generating a package for, say, internal consumption. So we have lots of NuGet servers here at Health Equity, and we had NuGet servers at my last job, right? So those are things that you could also do at your company. So instead of having to manually copy in some code, you can create your own NuGet package and whatnot. Obviously, there's a number of defaults here that aren't particularly useful, and NuGet is actually smart enough. If I leave these defaults, it'll actually warn me or blow up. I don't remember which. But it does. It'll tell me, hey, you have defaults. This is probably not what you want. So that's kind of nice. So with that, I'm going to delete this generated one because it's easy enough to use the one that we already have. So I'm going to go rename item here and simple app new spec.temp, and we're going to name this to our new spec. Oh, I haven't deleted it yet. New spec. Okay, so now let's go back to GVim and we'll open that back up here. Okay, so this one is basically the same. I actually just deleted some lines, but for sake of illustration, I wanted to demonstrate those properties that we tried specifying on the command line. So here we have title, version, ID. I'm still going to let those come from the CSproj file. And we are actually going to execute against the CSproj file still. However, it is going to match by convention the name of the CSproj file with the name of the NuGet file less the extension. So as long as the two names match, it is going to pick up that new spec file that we just created. Now, it named it appropriately when we generated it. So if you use NuGet spec to generate that NuGet spec file, you'll be in good shape in terms of naming conventions. So with that, let's go back to, I'm going to go to properties here. So here's that command that I ran earlier. We're still going to target the CSproj file, but now, because this is my lowercase version, this should work without our warnings. And voila, it worked. Okay, see? So we now have a NuGet package. Now let's take a look. Let's see if this looks any different. So here we have the owners and authors. So it picked that variable up. It substituted in using the properties that we specified on the command line, and same with description. So with that, we have a NuGet package that has no dependencies, right? And it works. So now, does that answer your question, right? So we have a CSproj file, we have a new spec file, they work together in concert. There's some limitations if you target the new spec file directly, but that's section 6, right? That's when we start talking about targeting multi-frameworks and other stuff like that, which we'll get to. So at this point, it's generally easiest, unless you're trying to target multiple frameworks, just to target the CSproj files directly. Okay. Any questions before we move on to section 2, which was looking at projects that do have dependencies? No? Okay. So we'll close that. So, okay. Back one more. So we're going to go to number 2. So this is a similar project, but rather than having, and let me just go to Visual Studio here. Okay. So rather than having no dependencies, so again, there's a README for these. That we'll see later. We have, this is actually almost the exact same. The only difference is, just for sake of illustration, I said, hey, I want to print this off as JSON, so I pulled in Newtonsoft.json. And with that, we now have a dependency. So if we go to our references, we can see that I have Newtonsoft.json as a dependency. And if we take a look at the packages.config, which is where the list of dependent NuGet packages exists on non-.NET standard, .NET Core type projects, we can see that we have that particular dependency. So otherwise, this is equivalent to what we had before. Now, one of the things that I did not say in that first one is that we actually have to build the projects first. I've already done that, but if you haven't built your project, then it's going to error out saying that, hey, there's no files and whatnot. So with that, let's go to the actual project here, and we're just going to do the same thing. So at this point, we have already, let me rename this again. So I'm going to rename simple deps new spec to simple app deps dot temp. Oh. Okay, so let's generate one and let's see what it does for those dependencies. So we're going to run NuGet Spec. We're going to give it that simple app with the CS proj file. And we're going to take a look at that simple apps NuGet file. So again, we have the same placeholders type content. And it did not list, when we generate that particular one, the dependencies. So, which is interesting. So let's see what happens if we try and just generate the NuGet package using that default one. So I mentioned before it'll kind of warn us about some of the default content. So let's just take a look. And again, I'm going to give it that CS proj file, but that as a part of the big build process, it's still complaining about authors and description. So let me go to properties here. And for the most part, this is what we want. But now we have deps, and I want the CS proj file. But I'm going to use those same properties. So here are the warnings that I told you about. So it did generate it for us, but we have some warnings saying, hey, you know, all of these, you know, remove them, do something with them. But what's more interesting, though, is let's see what it did with the actual dependencies. So we still don't have these dependencies listed, which is a little sad. So let's delete that. And now let's actually, I'm just going to rename it in here. So, no, I am in, that's the wrong one. With deps. Okay. Okay. So even though it did not specify the dependencies in that new spec file, it is going to use that CS proj file to pick up that list of dependencies. And also note that it even picked up the version for us. So if we update those NuGet packages and we generate, it takes care of that. So we don't actually have to maintain that full new spec file ourselves. That's one of the benefits of targeting that CS proj file. Okay. So with that, let's take, actually, let's go back here. So here we have the dependency. Basically what that means is if we look, we don't include it in the content, but instead it is listed as a dependency within the metadata, so that when we do that install, so if we install this NuGet package that we just created, it's going to say, hey, this guy has this as a dependency, therefore let me pull it in. So when we're generating NuGet packages, we do not have to worry about all of these other NuGet packages that we have dependencies being physically embedded in our particular generated NuGet package. So with that, we have generating a NuGet package that has dependencies on other NuGet projects or other NuGet packages. The next thing to add in is to complicate this a little bit by saying, okay, what if I have a project dependency? So project 1 depends on project 2, and both of those may depend on other NuGet packages. So that's what we're going to go to next. So if we go to example C3 here, that's what we're going to see. Again, we'll take a look at the structure here within Visual Studio. So we're going to go to 3, multiple depths. Okay, so in this one, this I will talk about later. This is here strictly as an example of some advanced features. But it is not actually relevant for most of this particular illustration. So if we look at the NuGet packages consumed, this particular NuGet project, so this app with multiple depths, depends on this app contracts project, so our other project in the solution, and these NuGet packages. So there is a bouncy castle, which is for cryptography. We have MailKit, Kit and Newtonsoft JSON, which are other dependencies. And basically the way this is set up is, if we look at our email confirmer here, it has a dependency on this email sender, which is defined up here in the contracts. So that's kind of the relationship that we've established. And if we look at the references, you'll see that app contracts is a project dependency. Okay, so with that, we're going to go back to the command line so we can see what happens. Now, the way that we are building these NuGet packages is to target the CS proj files, which means we're not doing it holistically at the whole solution level. So it would be kind of convenient if I could say, hey, I want to run it against this, therefore build this project and build this project as the NuGet packages and everything, but we can't do that. So we would have to generate them one at a time. Now, it is not going to tell me if I build app with multiple deps that I haven't already built this one. So I just have to kind of keep track of that in my head. So, or if we've already published it, then I can ignore that step. So with that, let's build another NuGet package. So, so let me go to that app with multiple depths project here. Oops. And I have a new spec file. This looks almost exactly like those other ones here. So again, it does not specify those dependencies. I have defaulted owners and description now because I don't feel like specifying properties anymore. So we know how to use those. So we're good there. And these ones, or ID, version, and title, are still going to come from that CS proj file. So let's go ahead. We're going to NuGet, we're going to say pack, and we're going to target that CS proj file. And let's see what it does. Okay, so we've generated the NuGet package. And if we take a look at this, see, we have dependencies, this Newtonsoft.json, but what happened to my project reference? So let's take a look up here. So I just have simple app with depths. I don't have, am I in the wrong folder again?
Do the dependencies cascade? So would it show you
Yep.
what Newtonsoft.json depends on in turn?
Let's see here. So he's right. I was in the wrong folder again. Have it for the day. Oh, okay. Better. So I have Newtonsoft.json. I have MailKit, but if we look at this, I still don't have that project dependency. The reason for that is I actually have to tell it if I want to include projects as dependencies. So if we go back to NuGet help pack, what we're going to see is there is this include referenced projects option. So in order for it to manage this, it doesn't really know if I want that project as or something that exists on the physical file system. So for example, let's see if I have MS Build in the command line. I don't. I'm in Visual Studio here, so that's just my little, or PowerShell, so I'm going to run my little convenience thing so I can run all of my Visual Studio stuff here. If I run MS Build, and I'm just going to run the build target, and I'm going to generate the on this project. Okay, so this will actually build the project, and what that should do is if I'm looking at my bin debug directory, I have app contracts here. So I'm going to run our pack command again. So, no, not that one, this one. Again, without that include reference projects. Oh, I have gallery open here. Let me close that. And if we come back, I'm in the right one this time. What we usually see is that we will often have that dependency right here. I'm actually surprised that it didn't have that. But let's take a look at what happens if we include that option which tells it that I care about the reference project. So if I do this, the structure is going to be different. And now you can see here we have app contracts. as a NuGet dependency. Oops, it's trying to load it. I did not want to do that. Again, it's not present there, which is what we expected. Now, anytime you have a readme.txt file, it's automatically going to show up as content. So if we expand this, the readme.txt file that I have included, which is basically the instructions on how we build this whole thing, is automatically present. This is what gets displayed to the user at the time they install this NuGet package. So it's not what we would want for content if we were publishing this for sake of illustration, or if we were publishing this out to a standard NuGet gallery, but it is useful for our purposes. Okay, so at this point we can build NuGet packages. Yep, Tom?
Okay, say something. So when you did the include reference projects, his app contracts had a new spec file on it, right?
Yes, it did.
And so it added as a NuGet dependency. If it did not have a that new spec file, it would include it in the actual NuGet package that he generated there. As in the lib folder there.
So that's why it wasn't there. Yep. And the first time I went through, I didn't have the new spec file, so that makes sense. That's why I saw it that first time, because I hadn't yet created the new spec files. Okay. So thank you for the clarification, Tom. Any other questions? No. Okay, so on to, before I jump too much farther in, I want to go back to a couple of other things. So again, like I said, these versions are different based on the Visual Studio version, which is important. And one of the things that I mentioned I would talk about later is versioning. So right now I left all of these as version 1.0.0. But the way, if we were to look at the NuGet documentation, what it's going to tell us is that versioning should be done according to semantic versioning. And there is a site called semver.org right here, which defines the versioning process. Now, what we have is major, minor, and patch. So usually when we're talking about this, we had 1.0.0. We might have, the 10.0.3 that we saw in the newtonsoft.json package. What that does is that tells the consumers of the NuGet package that when I change from version X to version Y, what I can expect. So if this major version, so if I go from version 10 to version 11, then I know that there is some sort of a breaking change. In other words, I cannot assume that if I go from version 10 to version 11, that I will not have to modify my code in order to build the project. I might have to make drastic changes. I might have to make no changes but recompile. Or I might have to make simple changes, right? And that is kind of up to the user. Now, the minor version, that middle number, basically says if I'm going from 10.1 to 10.2, then I am releasing new functionality, but I haven't broken any of the functionality anybody else has depended on up to this point. So that is very important that we follow, because if we don't version correctly, then when someone pulls down a new package, say I went from 10.0 to 10.0.2, and now all of a sudden everything is completely breaking, they're going to get frustrated. Where NuGet is smart enough to say, hey, I'm only going to pull down the latest. So we have the option of doing a safe install or a safe upgrade, which basically means pull down the latest version, which is compatible with the version I already have. If we don't follow semantic versioning, then that is broken. And then this patch version is basically saying, I've made some sort of a bug fix, so it is useful to grab this package, but again, I have not broken any functionality that you have depended on. So the versioning is important. Okay, so after that little aside, we're going to jump into the .NET Core / .NET Standard side of things. Yep. So we'll start with you.
Once upon a time, there was versioning syntax you could put in this new spec to lock it down to a very specific version down to the patch. Is that still in
In the new spec or in the packages.config?
You can say at least this version.
So are you
or
talking?
the syntax to log down to a very specific version.
Okay, let me see if I have a new spec up. So here's one. Okay, so there's a little room for confusion there. So first, when we specify, the version right here, there is no particular range. It is an exact number.
No, the dependency.
Yes, that's right. That's what I was just going to get to. Okay, so when we specify the version of our package, we have to follow semantic versioning and give it a particular version. However, if we don't do that, then we're going to get some defaults. So this is our app with multiple depths, so I haven't moved on to the new piece. But we're going to notice by default, it gives us this little greater than equal to. So by default, it is doing effectively kind of what you did, saying, hey, as long as it's at least this version, then we're good. If you want to define those versions manually, then you cannot target, when we run that pack command, we cannot target the CS_proj file. We have to target the new spec file directly, which means we are taking additional responsibilities upon ourselves. But it does give us the freedom of specifying the exact version ranges that we want to allow with our package. So that is an option. And I think I saw another question also. Yes?
Did you go into Visual Studio first and create a project? I guess you did that, right?
Yes.
Okay, then on your command line, you navigate to wherever the project is, and you're working from there. Is that what you're doing?
Yes.
Okay.
That is correct.
And in order to be able to use NuGet, you've installed some whatever.
Yes. So if we go back to the website right here, and I grab this, it's actually giving me a binary. And I just copied that binary into into a directory that I had in my path, or added my path, that directory to my path, so that I can execute it from the command line. Okay, so good clarifications. Any other questions? No. So we're good for the moment. Okay, I'm going to go ahead and close this. Since we're moving on, before I forget, I'm going to go ahead and switch to this other one here. Okay. Okay, so we're going to net standard app with, we could do no depths. We could actually jump to app with multiple depths. Let's see, we're at 710. Let's do that. So .NET Core provides a different means of generating the NuGet packages than we were just using. So I'm going to switch to that version 5 because all else being equal, the things that we're going to discuss are applicable to both cases, and the differences we have already addressed. So we talked about the include reference projects. That applies in some ways with both, but there's some new functionality available. Okay, so let me go to our net standard app with multiple depths project. So again, we have kind of the same structure. So here we have a CS_proj file. We can generate our new spec file. So let's run NuGet pack. We're going to generate that new spec file. And if we, oops, I won't give it pack. Sorry. Okay, well, as you just saw, we cannot run the exact command that we were running before. That process has changed. So what I meant to type was spec so that we can actually generate our new spec file. So generating the new spec file is exactly as before. So if we take a look at that, it's going to be generated in exactly the same way as it was before. For the sake of this, I'm just going to do some really quick edits, so I don't have to specify any properties or anything like that. Description. Oh, and it'll complain about tags also. Okay. So with that, we have a NuGet, a new spec file that we can use. So if we don't run this NuGet pack command, as we just attempted to do, then there's a different way, and that is in .NET Core, .NET Standard, we now have a .NET command. So if I just type in .NET, I can say, okay, well, okay, there's options, and I have the option of doing this application. So what are the options? Well, one of the options that we have is pack. And basically what that means is this is equivalent to our NuGet pack. So we can say .NET pack, and if I just hit enter in this particular project, it's actually just going to look at, and notice that it's running MS Build here, but it's going to look at what I have in the file system, and it's going to try to be intelligent, and hopefully it's not too slow. Okay, so it picked up that we have an app contracts dependency. This is the exact same project that I was using as on the other side. And we can see that it actually took, it built, or it picked up app contracts. It picked up that I have my simple project right here that has a associated DLL, and it generated our NuGet package for it. But notice that it put it in the bin bug directory. So if we go dir here, it's not in here like it was in the .NET Classic structure. So now we can go to, actually I'll just do dir bin debug. So there it is. So this is the actual content that was output, and here is that NuGet package. And if we go, I'll just browse to it on the file system here. But we decided to go on to Net 5, so we have a little bit more time for some of the more advanced topics here. We can go to our bin debug, and here we can see that NuGet package. And by default, because I had that new spec file, here we have our app contracts. It is going to add some other things, some other functionality. So it's going to say, hey, I exclude the build pieces and the analyzer pieces and whatnot. But I depend on app contracts, the net standard library, and newtonsoft.json. There, just as a matter of note, there is also a .NET Restore. So if you just need to restore your NuGet packages now, it's also built right in, so that we wouldn't have to go and download those. Okay, so we've generated NuGet packages for classic applications with and without dependencies. .NET Standard makes it much easier. And if we were to actually take a look at why this particular that pack command failed at the time that I attempted to run NuGet against it, and that is the CS_proj files for the .NET Standard, .NET Core Pocket packages are completely different than the old ones. So the NuGet pack command is not fully aware of all of those changes, and rather they moved that functionality into the .NET Core command. So just note that that's why it fails. Now, as you can see, there are values here that I specified. Now, some of these, like this, are automatically included. The rest of these are actually required in order to build that NuGet package directly. And if we were to take a look at the documentation on generating NuGet packages, it's going to tell me that if you want to use that .NET pack command, you have to add all of these properties. And you can if you... so there are additional ways that we could use to specify these. This is probably the most convenient, so that's what I was going to focus on today. Okay, so with that we have, and we also see that rather than having that packages.config, the dependencies are as package references. So this is a NuGet dependency, and then this project reference was turned into a NuGet dependency as a part of our build process. Okay, so that leaves us with how do we target multiple frameworks? Any questions before we go on to that last piece? No. Okay. So let's take a look at that on the file system just to get a general idea of what we're looking at. Now, once we start targeting multiple frameworks, we are taking a lot of the responsibility that we got for free by targeting that CS_proj file or using that .NET pack command upon ourselves. Which means that rather than it specifying exactly what I want, rather than the NuGet pack command specifying where the DLLs that it was aware of should end up in the NuGet package, we actually have to structure the NuGet package in the way that is most appropriate. So which means if I go to app with multiple depths, what we're going to do is we have that new spec file and we have to fully define it. Which that means I have to say I have dependencies. In order to target multiple frameworks, I also have to say I have a dependency group. I have one group of dependencies that is specific to .NET Standard, in this case 1.4. And the documentation lists off all of the allowed values here, excuse me. And then I have another set of dependencies for .NET 4.6.1. And then we have to specify the list here. So again, this is one of those things where I could say, I want to include everything from 1.0 up to 2.0, but excluding it. So this is that syntax that was referenced earlier where I can say, hey, I do have a dependency, but I can be fairly loose in the versions that I accept. So we could do that if we wanted. The other thing that I can do is I can specify, if I want, the exact files that should be there. I can specify wildcards. I can specify excludes, and I can specify where in the generated NuGet package they can go. Now, I chose not to use this approach and rather say, well, I know what the convention is, and for me, I thought it was easier just to say, I'm going to put them in that correct structure on the file system. So that lib folder that we kept looking at as we were examining NuGet packages, I had to match that here. And then we can say, okay, well, I have a net 4.5 and I have a net standard 1.4. This net 4.5 is actually wrong. I'll demonstrate what that looks like here shortly. And then I have the net standard 1.4. And within there, I have the files that are, that I wanted. So I have to make sure to include, if I want the PDB, if I want the XML documentation file, I can include those. And if we look at the net 4.5, it's basically the same thing, only I don't have to have, that depth list file here. Okay, so with that, in order to build, we are back to running the NuGet pack command. So let's go to the right location. So I want to go to 6, targeting multiple frameworks here. And I'm going to go to app with multiple depths. Okay, so I'm going to run NuGet pack, and this time I'm going to operate directly against that spec file. This is the first time I've done that, and by doing that, so as I said, since I did not specify, this is actually kind of a good example, since I did not specify the files that we have right here, it's picking up every single file in the file system, and my editor here happens to create a swap file that's locked, so it failed. So we'll run this pack command again. We see that it generated it, and again, just like before, it's actually going to generate it right in that directory. So if I open this up, we'll see, okay, I now have .NET Standard version 1.4. I have .NET Framework targeting 4.61. And I can see the dependencies that I have listed. All of that is perfect. As I mentioned, there was one slight mistake, and that is if we come here, this is targeting .NET 4.5, as you can see by this comment up here. And yet, I told it right here, this is 4.6.1. They need to match. Now, I could target 4.5 if I know this also works for 4.6.1, 4.6, and all of that, right? So we don't have to generate it for every single version. But know that, like I said, it's going to do what we tell it to, and it may not be correct. So we just need to be a little bit careful about that. Okay, so with that, we are almost done. So we've already went through most of this. Okay, so here is kind of the summary, the cheat sheet. There's one other piece back on that first slide that I want to go back to really quickly in the last 9 minutes. For the most part, we can use the exact same command to generate the new spec files from the CS proj files. But in order to generate NuGet packages, as we saw, in some cases we'll run NuGet Pack. But for .NET Standard, .NET Core, we're actually going to run .NET Pack. This is actually an alias for MS Build with a target of Pack. Note also that, and I didn't demonstrate this, but we can actually target the solution. So we no longer have to build the NuGet package one at a time. I can say build the NuGet packages for the entire solution, which is very nice. It's very convenient. So that's a nice new feature that they added. Lastly, if we target the new spec file directly, as we see, we can do it based on convention. We can use the files element to specify where all of our files are going to appear. Okay, so with that, there was one last thing that I wanted to talk about, which is this. So if we want to package NuGet packages that have symbols, or if we want to publish symbols, and then how do we actually publish to NuGet servers here? Okay, so let's see. I am in the 6 targeting multiple frameworks. That will work fine for this particular example. So I'm going to run NuGet help pack just to see what our options were. So we had properties. But there is also this symbols option. This allows us to say, I want you to generate a NuGet package that has the corresponding symbols. Actually, I think I want to go to a different directory because we'll get a better example if I go to something that actually has source code. So I'm going to go back to 3. This part works the same in all cases. So I'm going to go app with multiple depths. And then I'm going to run NuGet Pack. I'm going to give it the CS proj file, and I'm going to say symbols. Okay, now notice that it generated 2 packages. So we have app with multiple depths.new package, and we have app with multiple depths.symbols.new package. So let's actually take a look at what those are. So I'm going to go up to 3, which is the one that we were working with, and we're going to pull open the symbols package. Notice now that I have a source directory. So we had the lib and the content folders before, but I actually have all of the source code, which in my case was 3 files, in the NuGet symbols based package. What this means is if I publish both of those, then people can actually download, and you can set up Visual Studio to integrate nicely with this, but you can actually have it download the source code for packages that we have published with symbol support. So now they have a nice, easy, convenient way to get the source code to packages that we have made open source and stuff like that, or even internal. So just know that that is an option. Okay, so lastly, we have NuGet servers and publishing. So before I go too much to the publish side, so this is one of the NuGet server options. This is the NuGet gallery. Now this is the public source Microsoft hosted one, but we also have the ability, this is actually open source. So we can actually download the source code and build this from scratch if we want, or we can download a binary for the NuGet gallery and we can host it internally. There are some benefits to doing that, but there are also some lighter weight ways that we can do that. One of those is to use I think it's just NuGet.server. Yep, so right here, this NuGet.server NuGet package is a NuGet server. You can basically install this into a web project. So you create a web application project, pull this in, it will hook into your global ASAX or your ON middleware, and it'll actually stand up a very lightweight NuGet server that you can use. So this is also another option. There is yet another lighter weight option, which we're just going to do really quickly as an example, and that's we can do a file system based deploy. Now there are 2 different structures for the file system based deploy. One of them is hierarchical. that is the one that you want to use. Then there was an old flat file system, and basically what that means is every single NuGet package goes in that exact same directory. So if you're publishing like hundreds and hundreds of packages and all have hundreds and hundreds of versions, it starts taking forever to search. So you don't want to do that, but that is, kind of the conventional way. Okay, so with that, we now want to say, hey, how do we actually generate that NuGet package? Again, we're going to just take a look at help really quickly and see which of the options looks most useful. So here we have push. It says pushes a package to the server and publishes it, and then it's going to tell you where the configuration can come from. And then we also have add. Okay, now add says adds the given package to the hierarchical source. This is the one that if you're going to use a file system-based deploy, you want to use. And the reason for that is each NuGet package, based on the ID, gets a folder. So when your Visual Studio goes to search through all these packages, it can say, oh, I just queries the directory list, and now it has a list of all the packages, and then it can go into the directories that you care about to get the actual versions. So it's much more convenient. So let's just go NuGet help add, and let's see what the command's going to look like here. So we have add, we have a package path, and then the source. So this is basically where we want to publish it. And then they have some examples. So add food package, our source, bar packages, or you can do just a file system based deploy. So which is what we're going to do. So I'm going to do dir. So we already have a package. So let's just do make dir. I'm just going to call it hier for hierarchical. So now we have a directory that we can put it in. So let's go NuGet add. We're going to give it our app with multiple dependents new package file. And let's see, our source is going to be that hierarchical folder. So with that, it says it worked. We can cd to that folder. If we take a look, we have app with multiple depths. Again, that's the name of our NuGet package. And actually, let's go up here. And within there, again, we have a folder for each version. Here's the NuGet package file. For the sanity of consumers, it gives it there's a SHA-512 checksum, and the new spec file so that the consumers don't have to look inside the new package to find out what the dependencies and stuff like that are. And this is the new spec file that we generated, plus all of the dependencies that are automatically included by Visual Studio as it goes through and runs that NuGet pack command. So if we take a look at that, we can see here's the dependency list. Because we did not have, we weren't targeting multiple .NET Framework versions, we don't have that group specifier that we saw earlier where we had that group right here. Okay, so with that, we have 1 minute left. Any questions before we finish up? Mark?
How does NuGet compare to NPM?
They are both similar in that they both have dependencies. They both allow you to specify versions. NuGet is generally a little bit smarter about updates. So if you say, hey, I want to update my package to this latest version, NPM, a lot of times it won't update a lot of those dependencies. NuGet typically will. For the most part, they're very similar. But I am not actually familiar with the structure of the underlying NPM packages. So, answer your question?
When do you use tags that you showed in the spec file?
What was the question?
The tags.
Oh, the tags. So tags are convenient for searching. So if I'm interested in SMTP related libraries, so let's go take a look at the gallery here, and I'm just going to type in SMTP. If we look, ideally, we will have a tag, and notice that we do right here. Let me increase the font size here. See, we actually have a tag for SMTP. So anything you think someone might search on is something that you should probably have or might want to consider at least putting as a tag for your NuGet, for your new package or I should say in your new spec file. They are space-separated list of values. So usually you will just use single words or you'll hyphenate if you want multiple. Other good questions? Okay.
It seems like
Mhm.
you're building your own NuGet package because you've got a lot of common code that can be used across your application, right?
Yep.
And no sense to duplicate it every time, but just build a NuGet package for it. And
Yeah. So say, for example, you're going to be using microservices architecture. In that microservices architecture, there's certain things that are common, right? Logging. But say you need that logging, you can't just use Log4Net because you want everything going to a centralized NuGet server, or not NuGet server, sorry. I've been talking about NuGet a little bit. You want to get everything going to a centralized logging server, right? So you're going to have some code that tells it where to go, look at the particular logging server of interest. You're probably going to want some code that does authentication that's common to all of them, setting up bearer tokens or something like that. So all of those are good things that are likely targets for NuGet packages, even within a company that's not publishing at the open source level.
yep.
Like adding settings to your app config, the web config,
Yep, so there are some conventions that will allow you to automatically add things like a targets file to your build project. At the moment, there is an install.ps1 script, so a PowerShell script that you can put in a tools directory. So again, that structure that we are looking at is convention-based. So we had a content folder for stuff that's just going to be dropped directly into the file system. We had a lib folder for the assemblies. There's a tools folder for executables. In that tools folder can be install.ps1 and uninstall.ps1 that are PowerShell scripts that will run, and they'll be passed certain parameters. That's more advanced. We're not going to talk about that. But that can do things like add settings to your app config at the time you do the install. So again, another great thing that you can do with NuGet, but a little more advanced than a lot of people need. Additional questions? Okay, well, thank you. If the recording worked, then I'll have it online.
Oh man, let's clap.